Hello everyone. Today we are presenting our work on GazaVHR, a dataset and pipeline that leverages artificial intelligence, specifically vision language models, to support the documentation of potential human rights violations in conflict imagery from Gaza. My name is Dilara Zeynep Gürer, and I will be presenting this work together with my colleague Nesibe Şebnem Paluluoğlu. We conducted this research with our instructors at the Institute for Data Science and Artificial Intelligence at Boğaziçi University. Monitoring human rights violations in conflict zones like Gaza is extremely difficult due to the limited on-the-ground access. To address this, researchers increasingly turn to user-generated content from platforms like Twitter, TikTok, and review websites. These platforms provide valuable insights into public sentiment, mental health, and crisis responses, often through personal stories and real-time reactions. At the same time, machine learning and computer vision have shown strong potential in detecting human rights violations using social media, web images, and satellite data. Tools like CNNs with transfer learning support abuse recognition, while Twitter and Telegram enable content classification. In cases like Sudan, satellite imagery combined with feature extraction was used to identify burned villages, highlighting the role of visual data in HRV monitoring. Overall, citizen-shared media has become central to real-time, large-scale documentation of potential violations, laying the groundwork for our own approach in Gaza. Despite extensive research on human rights violations, there is currently no study focused on the recent Gaza conflict. There is an urgent need for scalable tools to document potential violations in Gaza, especially because manual verification is slow, limited, and impractical for large, fast-moving conflicts. The huge volume of social media posts and images means that human-only processing can't keep up without automation. Our goal is to support humanitarian actors, legal experts, and policymakers by providing legally grounded documentation of potential violations. To do this, we use visual language models and semantic clustering to extract legally relevant evidence from social media imagery. This approach bridges AI capabilities with international legal frameworks such as the Rome Statute, making a concrete step toward strengthening international legal mechanisms and helping prevent future violations. To analyze visual user-generated content related to the Gaza conflict, we collected tweets containing images posted between October 7, 2023 and March 10, 2025. Our script automatically extracted the top 5 global and Turkish-specific hashtags each day from the publicly available Twitter trending archive. We manually selected hashtags, and using a third-party data partner, we retrieved nearly 146,000 tweets, extracting around 177,000 images. On the other hand, the evidence dataset is a curated set of 231 expert-verified images from Anadolu Agency photojournalists during the Gaza conflict since October 2023. It links images to the Rome Statute Articles 5 to 8. The dataset also documents Geneva Convention violations. It has evidentiary authority cited in amnesty reports and used in the ICJ case South Africa versus Israel. This legal grounding ensures our analysis aligns with international human rights standards.
Hi, this is Şebnem. Here's an overview of our pipeline. As my colleague Dilara mentioned, we started with approximately 170,000 images, and after a series of filtering and classification steps, we proposed that 4,603 of them are likely to depict potential human rights violations. Here's a step-by-step breakdown. As an initial step, we manually reviewed the dataset to identify prominent patterns, and we noticed that there are numerous AI-generated images. So to address this, we employed the ICML'25 78 billion visual language model to filter out this synthetic content. So we divided the dataset into 3 classes and proceeded with the real photo category. The majority of the filtering occurred during this phase because nearly 60% of the original dataset were removed here. In the second content filtering, we again reviewed the dataset manually and identified the most common and recurring categories. Here we removed celebrity, protest, adultery, textual, and neutral portrait, and we continued the analysis with the rest. The next step was duplicate removal. At this stage, we applied a 2-step duplicate removal process. First, we computed the SHA to 56 hashes of raw image bytes to identify and eliminate exact duplicates. Additionally, the dataset contained near duplicate images such as cropped versions of the same image or photos taken from slightly different angles, etc. To detect these, we extracted image features using a pre-trained ResNet 18 model and computed cosine similarity between image embeddings. By applying a similarity threshold of 0.9, we effectively removed near identical content while preserving meaningful variations. For the downstream steps of noise reduction and evidence alignment, we have used the semantic embeddings. The noise reduction process began with feature extraction using intern vision transformer 6 billion to generate 3,200 dimensional embeddings. We then applied UMAP for dimensionality reduction, followed by HTB scan. Here, the circles represent the reference dataset, and initial clustering results show that the significant majority of the reference images grouped into a large cluster, while outlier clusters are also visible. We kept this biggest cluster, and through manual inspection, we identified the irrelevant clusters and removed them. In the last step, we again use the same semantic embeddings, but this time we have changed the UMAP and HTTP scan parameters to differentiate the articles from each other. So our objectives were first, to identify the images that align with our reference dataset, and 2, to discover potential human rights violations that are not covered in this reference dataset. Ultimately, we got 135 clusters in total. 34 of them contain our reference images and the rest does not.
So our work demonstrates the power of vision language models for analyzing conflict-related images at scale. It provides a valuable resource for humanitarian and legal investigations. By combining the structured filtering with expert-aligned legal references, like the Rome Statute through the evidence dataset, we ensure the analysis is both robust and legally relevant. There are some limitations to our work. Only a portion of the images have been extracted, and the dataset lacks full manual verification, which may impact precision. Our next steps include expert review of evidence-aligned images to validate potential human rights violations. We will also analyze the remaining image clusters using vision language models combined with expert input. Once finalized, this pipeline can be scaled to process even larger volumes of images.